I am sure you have all heard something about black holes, but I am sure what you heard is wrong. In fact, more than 50% of the students in the MIT think that a black hole is a vacuum cleaner, but a black hole is not a vacuum cleaner. It's a place where the laws of physics break down. But before we break the laws of physics and jump into a black hole, first we have to find out how gravity works.
So, if I have a planet here, and I have the sun here, then the planet feels the force of the sun, even though they're not touching each other.
Let's say I have the Earth and the Moon here. How does gravity communicate from the Earth to the Moon? There must be something hidden out there that we can't see connecting them together. But what is that thing? It's Earth and the Moon, space. I don't mean outer space, I mean the space between things. To get a feel for what I'm saying, let's remove everything from here. I mean everything. The people, the cars, the Earth, the galaxy. And not only the big things, but also all the atoms in the universe. What will I be left with? Most of you will see nothing, but nothing is something. It is empty space. Imagine if this was the smooth fabric of space. If I roll an object on it, it will move in a straight line. But if I put a heavy object on it, it will warp and curve like a rubber sheet. So if I roll this object again, it will follow the warps and curves created by this heavy object. This is how gravity works. It's the warps and curves in the fabric of the cosmos. But in order for this theory to work, you have to combine space and time together. One way to think of time is to think of it as an extra dimension. Let's say I'm meeting a teacher at 12 o'clock in Estrobu International School in the 3rd floor in the Makerspace room. In order to get to this meeting, I need 4 bits of information. 3 for the 3 dimensions of time, up, down, right, left, and forward and backward. And 1 for time, the 4th dimension. Now I'm standing, and most of you will say that I'm not moving. And you may be right. I might not be moving through space, but I am moving through time. So if I start walking now, my clock will start ticking slower. Because space and time are one thing, and your motion affects the rate at which your clock ticks. And this is called time dilation. Your clock also slows down near massive objects. In fact, clocks in high Earth orbit tick faster than clocks on the surface of the Earth. And if you don't put this into account, GPS does not function properly. Hold on to these thoughts for a moment. I think now we're ready to jump into a black hole.
A black hole is something that's very, very heavy. You have a lot of mass compressed into like one small region.
So what is a black hole? Well, in the Newtonian sense, you would say a black hole is a massive object which, like the Earth,
A black hole is a region of space-time where there's the space and time is so much curved that light cannot escape from this region. That's why we call it a black hole.
Now, a black hole is what you could say the ultimate consequence of gravity.
What happens then if you have a space-time which is strongly distorted by a very dense object? For example, the center of a massive star which has exploded and collapsed on itself, and the star has exploded. That center can turn into what's called a black hole. And
a black hole is an object from which even light cannot escape And since nothing can travel faster than light, that means that nothing can escape, and hence it's black.
One way to think of a black hole is to think of it as an object that cannot resist gravity. For example, the sun balances the inward pull of gravity by fusing hydrogen together, which creates an outward push, and the two forces cancel out. When a star 20 times more massive than our sun runs out of hydrogen, it starts collapsing in on itself, and there is no force known to stop this collapse, and the star becomes a black hole. Another way of thinking of a black hole is that every object has an escape velocity. For example, the escape velocity on the surface of the Earth is 11 kilometers per second. If you want to launch a rocket into space, it will have to reach a speed of 11 kilometers per second, not be pulled back to Earth. In a black hole, the escape velocity is greater than the speed of light, and nothing can travel faster than light. And that's why black holes are black, because nothing can escape their surface, not even light. So if we can't see a black hole, how do we know that they exist? Scientists have methods to detect black holes. One way is to track the objects orbiting the black hole, and another way is to detect the gravitational waves created when two black holes spiral in towards each other using a sensitive interferometer, and there are many other ways. Where is the closest black hole? For more than a decade, scientists have been tracking stars in the center of our galaxy, and they discovered that stars orbit a dark, massive object 40 million times the mass of our sun. And this object could only be a black hole. But before we learn the fun stuff, let's first fix some misconceptions. Misconception 1. A black hole is not a vacuum cleaner, and you can orbit a black hole just fine. It's only if you get too close to it, the escape velocity will reach the speed of light, and we call this the event horizon. The event horizon is a sphere surrounding a black hole in which everything inside the event horizon will have to travel faster than light in order to escape the black hole. So why do objects fall into a black hole? For the same reason why apples fall onto the ground. They're not being sucked in at all. Are all black holes dense? No. The black hole in the center of Andromeda galaxy is as dense as water. Or you can view the density as a property of the singularity. What happens if you jump into a black hole? If you jump into a stellar mass black hole that is 5 to several times the mass of our sun, then you'll be ripped apart from outside the event horizon, and scientists call this spaghettification. But if you jump into a black hole that is, let's say, billion times the mass of our sun, then you can enter the black hole just fine. Is it possible to harness a black hole's energy to make science fiction a reality, like time travel? If you recall, in the beginning of the video we said your clock slows down near massive objects. So if you orbit a black hole for 1 or 2 hours, and you get close but not too close to it, then 50 years should have passed on Earth. And for you it's just a few hours. There are some theories that suggest a black hole is a gateway to another universe, but that is yet to be proven. There is a problem that bothered scientists for a while. The problem is what happens if I throw an encyclopedia into a black hole, will it be lost forever? Scientists discovered that anything falling into a black hole gets smeared out on its surface, so the three-dimensional version of it is lost forever, and the two-dimensional of it is saved on its surface. And in theory, we can construct the three-dimensional version of it using the 2D version on its surface. Could this mean that the three-dimensional world is just a projection of a two-dimensional sheet on a hologram?
That's not a question for physics, that's more a question for philosophers, I think.
Do scientists fully understand black holes? No. But when they fully unlock its mysteries, this could happen in 100 years or tomorrow, we will take a giant leap into understanding our universe.